that we had started at that time, and we can be able to remind ourselves as far as that work is concerned. But before that, on Monday, when I was coming back, I sent you some information. I mean some question, which is a principle used the map reading, the concept of detour indices, on the concept of detour indices, and we had given you the information and asked you to calculate the detour index, but it seems there is no one who responded. It was on the WhatsApp group. If there are some people who may have got it, then well and good. But because it possible, I later on thought that there are many of you who may not have carried out map reading, or may not have conducted, may not have gone to that extent of how to compute detour indices. Okay, it were many. I know there are more who may possibly join at by 2:30 there. So before that, let me just try to share the whiteboard, and we deal with that question concerning the detour index. Yes. Network went off, and the network went off. So we can still deal with this question about what is meant by detour index. So, anyone with an idea? Anyone who may be having an idea, or however minor, there's no need to fear. Any person may have heard what is meant by just hearing. Yeah. How about the word detour? What does detour mean? Let alone detour. What? Into Okay, I'm sorry. It seems the same issue has happened again. I don't know why it is stable today, but now I've removed some things. Okay, I was asking about anyone who may have heard about the term detour. Detour. I was talking of the road traffic signs whereby construction is taking place and there is some kind of a diversion. And at the diversion, they may have written there detour. Detour. So a detour is a diversion or an indirect route which may tend to be longer, or something I would refer to as a long cut. A long cut, that is a detour. Otherwise, the other one may be just a direct route or a straight route. A direct or a straight route. Just like if I may refer to this, let me see here. Let me share the whiteboard. It can be, there can be two places here. Then there is also another one here. This is place A, this is place A, and this is place B. The direct route would be a straight one from A to B. But then you may find that there could be some diversion or some kind of indirect route. The road, which may lead to this place. Now, this is the direct route. This is the direct, or the straight, or the straight route, While this is the road. This is the road, and in this case, it is since it is not direct, we could then refer to it as the what? The detour. The kind of the diversion or what may be indirect. So the detour is so, okay. The detour is this. Is the other one is there? The straight or the straight route. The distance via the road may be longer. That's detour is a long. It could possibly get longer. Then the shortcut, or which could even be I have been using this is Airtel network. I got the Freaky Friday, and I don't know whether it has such issues, but otherwise I've been using it for some time, and it has not been behaving in such a way. I still don't know what the cause is this time. Okay. So as I was saying, the road, there's what now we may refer to as the rod distance, rod distance. Then there's also what we may refer to as the what? The straight distance. The straight distance. The straight distance. Straight distance. The straight distance. This one is direct. Times may refer to it as the direct route. Direct route. Then this one is the possibly may be referred to as the what? The detour. The detour or the long cut. Now, the detour index. The detour index. The detour index, what you normally do is measurement of distance on the map. The measurement of the distance on the map, you may measure it along the road or the route the direct route then distance if the what this road distance as the straight by the road then you what 100. The whole thing is, or let me try to remove the video and then see if I will, it will be more what? More stable. Okay, I think that was the formula for the detour index. Let me just summarize so that we can now go back to what we're meant to do, since now we have more people there. Detour, the formula, I'm just going to give you the formula. Detour index is equal to the road or the route distance minus the straight distance altogether. Difference you divide by the what? By the route distance. Then you express it as a percentage. So this is from what we gave the other time. This is what you ought to have done. Okay. Otherwise, this is an aspect, a concept taught in your map reading. Okay. Now let us go back now to what the work we were given the other time. I hope you have done the what? The exercise, because we gave it to you. We said we'll try to go through it again. But now here we have this. This is the photograph. And we had said that to draw a landscape sketch of the area shown on the photograph, and on it mark a name, and on it draw a landscape sketch of the area shown on the photograph, and on it mark a name, 2 physiographic features, 3 land use types, the drainage feature, then the convex slope. So you draw what you see. There must be the title, which we did the other time, a descriptive title. It must be in a frame, Then it must be labeled. You must label those features there. So starting with the physiographic features. Physiographic features are the landform features, are the relief or the landform features as we observe here. So the other time we had taken note of the steep slope, which was here, the steep slope, which was here, then the gentle slope somewhere here, the hill there, the basin, a basin there. We talked of the lowland or valley somewhere here, lowland or valley here. Lowland or valley here. Then, which other landform? Possibly a spar here. Those were the landforms we had talked about. Then the land use types. The land use types we had identified are the road transport as seen here. You mark it and you indicate it. Then in forestry, where the trees are around here on the gentle slope and part of the steep slope. Then the settlements in the low-lying areas, settlements here. Then crop cultivation. You've seen crop cultivation in the valley or the low-lying area, and also on the steep slopes. This is crop cultivation, but possibly under terracing. You can see that. These were then we had said that the convex slope is this around here. This is the convex slope. This is what we had seen. The convex slope is here, which was specifically asked about. Convex slope there. Then the drainage feature. So this drainage feature, we identified it as a lake. So a lake, convex slope is here, and the other land use types and the relief features as we have done. We wouldn't wish to spend much more time there. Yes.
How can you identify the convex slope?
The convex slope. Okay, possibly that time you are not there, but let me try to go back again. So this convex slope, we shall also see more. You can identify it by doing what? By how it appears. You have seen this slope, how it bends like this. If you know what a convex lens is, yeah, that is how it is. So you just indicate here and say a convex slope. We shall see more about the convex slope. So this is the convex slope. Even here, this kind of slope you have seen here, the way it is more of convex. It's more of convex. Even this other one here. Don't you think this one is also more of convex? Convex slopes are those slopes which tend to bulge outwards. They tend to bulge outwards. So the convex slope. Otherwise, I think the other features you can be able to identify them. The other relief features, I talked of the steep slope here, the hill there, the gentle slope here, the valley or the lowland here, the spar here, and so on. Then the land use types, the forestry, settlements, road transport, and cultivation are the ones. The drainage feature is a lake. We have seen the lake in the background there. Okay, so we clear that, then we can then go to our next one. Okay, state the type of photograph. Even the other time we said this type of photograph is a ground horizontal photograph. You can see this hill here, taking the picture of this hill and taking the picture of this part here. Don't you think the cameraman, though he was on the raised land, was slightly raised, but the direction of the camera, the axis of the camera was horizontal. It is only that these parts here, this part, which was here, is on a lower land, is on a lower land. That's why it appears as if it was taken from an angle. But this one here, this part here, and also these parts here, and also this is sky, all suggests that the axis of the camera was horizontal. And I don't think this person was in a low flying plane. He was on the ground. So this is a ground horizontal photograph. Ground horizontal photograph. Okay. Now account for the formation of the convex slope, and also the drainage feature shown in the photograph. So what I think today we have planned to do is to account for the formation of the convex slope, accounting for the formation of the drainage feature shown in the photograph. Then also we may do a description of the relationship between the physiography and land use types in the area shown in the photograph. Then also we shall explain the value of the drainage feature to the people living in the area. So this is what we intend to do today. The other one was a review. We did it last time, but some may have missed it out. So now we shall start with these other ones. Now, account for the formation of the convex slope. Which was the convex slope? This slope here, So when a question says that account for the formation of the convex slope, it wants you to explain what could have brought out that is slope. But first of all, you have got to describe what that slope is, what a convex slope is. Of course, it is not only convex slopes that we may have, there are also other types of slopes in that category. The concave slopes, we also have the constant slopes, or the straight slopes, the constant slopes, concave slopes. Then we also have those ones slopes which are more or less vertical, which are the cliffs. Those are the cliffs. Okay, now let us go to accounting for the formation of the convex slope. So this one, I think we had also sent it to you. Accounting for the formation of a convex slope. So in the first place, what do you have got to define or explain what is meant by a convex slope. Convex slope. Convex slope is a bulging slope or a dome-shaped slope. It is dome-shaped or quite bulging. It bulges outwards. So it is an outward bulging slope or dome-shaped slope, like a dome. It is not inward curving. It is not inward curving, nor is it straight. So it results from uplift of land followed by denudation. Possibly the land had been lifted up upwards, some after of land. So that uplift of the massive rock would have been possibly a resistant rock. And this is followed by denudation. It is followed by denudation. So denudation is weathering and erosion. Weathering and erosion. So the raised land, the uplift or that land is weathered and then eroded. So the erosion may result into what is the process known as a slope decline or slope retreat. Now, slope decline was explained by William Davis. So slope decline is when the angle of the slope reduces. The slope tends to become more and more gentle. While slope retreat is when the end of the slope ends, its end shortens. It shortens. At times, it is also referred to as scalp retreat. So it is a erosion or the process of slope retreat and decline. Then this is due to the presence of hard or resistant rock, especially where it is bulging outwards. It is bulging upwards was because of the presence of hard or resistant rock. This resists the nutational processes, forming a dome-shaped or convex slot, So as so one explains this, and with that, then you have got also to illustrate, define what a convex slope is, the condition, the condition, which is the presence of hard or resistant rock, possibly integrated with the process of formation, which is erosion. So saying that the erosion is resisted by the resistant rocks. So now here you can see a diagram of the convex slope. So this is a diagram illustrating the convex slope. So you may say that this area here, which is bulging more, is what is possibly the more resistant. More resistant rock here. So that's why it has resisted. It's bulging what? Outward bulging. So then here, possibly, or originally, it could have been, land could have been up to here. Land could have been possibly up to here. So now, in this case, this one is eaten by what? By denudation. So now it is eaten. Now in this case, this is what we call now the slope has retreated. So from here, the whole of this part has been eaten out. So now here in this case, it is, we now refer to this as what? Slope retreat. Otherwise, slope decline is when it becomes what? Rather gentle. So as you have seen, you need to illustrate what is meant by a convex slope. So you can see this is slope. Bending outward bulging. So convex here, I think the spelling here got some problem of the what? Spelling. So it is a single N, yeah. But don't worry about that. Now, that time I tell you that next time it may not only be a what? A convex slope. So for purposes of learning, I have decided also to discuss other types of slopes, the concave slope, because next time you may be asked about a concave slope because they're all in the same category. But as far as this question was concerned, it was purely convex slope. But since we are discussing, we need to learn, we have to bring in these ideas as well. Now, just you follow the same trend, defining the process or the underlying conditions, then we diagram. A concave slope is an inward or spoon-like slope. It is an inward or spoon-like slope. Or it is a slope that tends to bend inwards. That is inward bending. That is inward bending, like a spoon, like the shape of a spoon. It's a spoon-shaped slope. That is a concave slope. It results from denudation or slope decline or slope retreat. So that denudation there is basically erosion, the process of erosion that erodes. So now in this case, that part which is eroded more than the rest is where there existed weak or soft rocks. This is due to the presence or existence of soft or less resistant rocks. This is due to the presence or existence of soft or less resistant rocks. These weak or soft rocks are easily weathered. They are easily weathered and eroded. Or lowered, forming a spoon-like shaped slope known as a concave slope. So it is basically as a result of weathering followed by erosion, where the section in the middle may be comprising of weaker rocks. So differential erosion weathers them more than the other section, so resulting into a spoon-like shaped or inward bending a mini slope. So this is the what? A diagram to illustrate a concave slope. You remember the one of the what? The convex one. Convex one was like this. Convex slope was like this, but now this one here, this one was outward bulging, while this one is inward bending. Inward bending slope. Inward bending slope, which is a concave slope. So it's the concave slope, possibly because around here, denudation was more than here and here. Okay. So we have looked at a convex slope, then we have looked at the what? Concave slope. So the concave slope, convex slope. Then there is the third one, which is the balance of the two. The one which balances the two, which is now rather straight. It is rather straight, and that is known as the constant slope, the constant slope. So next time you may also be asked to identify the constant slope. So you need to get the what? The information. Still the same approach. Define constant slope and explain the process and the underlying condition to that process, then illustrate with a diagram. So it is an even slope or a straight slope. A constant slope is an even slope or a straight slope. It results from denudation of the denudation process of slope decline or slope retreat. So denudation process, and that is what? Erosion. Erosion, making at times the slope to become rather gentle or its end being reduced. That is the slope retreat, or the what if it is with a cliff, it is normally scalp retreat. This is due to the presence of homogeneous rocks or of uniform resistance, homogeneous rocks of uniform resistance. There is a balance between erosion and deposition, resulting into the formation of a constant slope. So erosion is uniform. Even where it is deposited may also be quite what? Uniform. So the condition here is homogeneous rocks. For the concave slope, it is the presence of a softer rock at the central end, soft rocks. Then for the convex, it is more resistant rock. Yes.
So how can I identify the constant slope via the photograph?
No, it may not always appear. It may not always be the one in the photograph. We're just saying that there are places where, how can you identify it? By viewing, if you view a slope which is like this, which is straight, which is rather straight, which is not bulging outwards or which is not bending inwards. Have you seen that? Yes. Okay, you can ask. Yes.
The same stuff applies to the concave one, not so.
The what? Yes, yeah. One just that all their shapes differ. Have you seen the shape of this one? This slope?
Yes.
Yes, it is a straight, not so?
Yes.
Yeah, it is a straight, but the convex one bends or bulges outwards. The concave one is rather bending inwards, not so?
Yes.
Now, on a photograph, you can be able to see such type of what? Slopes. In the photograph we have here, we have here, it may not be clear, but at least on here, this slope bulging outward. So we see it as a convex. Now, like here, the road is this slope here to be bending. So around, let me get this in. Here you have seen that. So here, this concave. This would be Okay. Now there is this other one. I switched off my video, but I still don't know what is happening. Okay. I was saying that there is this bit here. I hope you have seen this is rather straight. So this is a constant. This could be a constant. It's a constant slope. This is a constant slope. This is a constant slope here. This one is a convex slope. We have identified it by their shape, So if you know the shape of the slope, then you are able to identify it on an area shown on a photograph or anywhere or on a diagram. In a diagram, you can be able to do what? To identify it. So the convex slope, a concave slope here, you can see it is here. Then this one, which is rather straight, is a constant slope. So these are the ways in which one may be able to identify. Okay, so we can continue with where we've been. So this was the diagram of the convex. Then the constant slope is here. Now, let me also show you the difference. Now here, I said there, So this would be the concave slope. This would be the convex slope, while this one, which is straight now in the middle here, straight is the constant slope. Now we also have in this category the what? The formation of the what? Of a cliff. Formation of a cliff. Formation of a cliff. There's someone who's asking for the convex. Convex is, convex is this one here. I'll slip back to the convex. The explanation is here. We spent a lot of time on it. This is the what? The convex. So for the one who has been asking. Now, the last one is in the same category. It is the formation of a what? Of a cliff. Now, this is a more or less vertical slope. This is a more or less vertical slope of very steep rock face, more or less vertical slope or a steep rock face, something which we define as a cliff. Times we call it a cliff face because it's a more or less vertical, a vertical slope, very steep. You can also identify it in an area shown in the photograph, but the one we have there, I don't think there is a cliff. If I may go back to the photograph, do we find anything like a cliff here? Here there may be no cliff unless it is some river or the lake cliff. Otherwise here there is no vertical slope. Here we have steep slopes and the gentle slopes. But in an area where it may exist, explaining the formation of a what? Of a cliff is that it results from the existence of massive hard rocks. Massive hard rocks there, then the surroundings are worn out. So it is due to the uplift of mass, of rock mass, followed by denudation, the process of slope or scalp retreat. Scalp retreat. So the rock, the rock which could have been uplifted is eroded, and it retreats. It retreats until when the whole thing is what? Flat. I mean a vertical. Just like as we were saying, if I can try to illustrate here. Now, it could have been like this. Now, you then find that the whole of this place, is now, eroded. All of this place is eroded. Then in the end, this place is eaten, and the slope which was here, it retreats. This slope retreats. So this process is now known as a scalp retreat. So the whole of this is eaten by erosion, and it retreats up to here, such that then in the end, in the end, you end up with what? With the such. You then end up with such kind of what? Situation. So now this one is the what? The scalp. The scalp or the cliff. The cliff. The scalp or the cliff. So it may also result from undercutting of rock. It may also result from undercutting of rock, creating a vertical slope or cliff. The undercutting of rock, creating a vertical slope or cliff. So formation, so when one is asked to describe the formation of a cliff, yeah, this is the content one will be able to provide. Then you add on the what? The diagram. So this is the cliff. This is the cliff. Or originally, it could have been like this. This could have been the original position. But because of undercutting, undercutting is when the lower ends, when the lower ends are eroded more than the upper ends. When the lower ends are eroded more. So this material here will be eaten up, will be eroded, process known as undercutting. Then in the end, you find that it will end up as a very steep slope or a vertical slope like this. So this is the cliff now. So we have looked at what a cliff is, the formation of a cliff. We've got the formation of a cliff, and we have said the diagram is here. We have also looked at we have also looked at the concave slope. It's the cliff, constant slope. Information about the constant slope is here. Those who may not have got it, you cannot be able to get it. There's someone who's asking about the concave slope. Concave, the diagram is there, but the explanation or the notes are there. The process of explanation is there for the concave slot. Then the convex one is also that which we started with and where we spent a lot of time. So the convex slot, which is outward bulging slope, the condition of the convex is basically hard resistant rock in the center. For the concave one, you'll see it's basically the condition is the existence of softer rocks, which are eaten more, resulting into an inward bending slope. An inward bending slope. Then for the constant slope, condition is homogeneous rocks. For the constant slope, we have an even slope. It is an even slope or a straight slope. All of them are because of what? Denudation processes of weathering and erosion. So constant slope, homogeneous rocks. That's the constant slope. Then the cliff is there, basically as a result of slope retreat or the scalp retreat. Normally massive hard rocks being undercut, resulting into slope retreat or the scalp retreat, ending up as a very steep rock face or a vertical slope. Is someone who is asking that are examples required? Yes, if it depends on how the question could have been asked. If it was asked in the geomorphology bit, section B, whereby it requires talking about the question can be explain the formation of the following features: A, convex slope; B, concave slope; C, constant slope; D, cliff. Yeah, then there you would explain them like this. Then you also cite what examples of where such slopes may be. It can be a local example. You can cite a local example. But for cliffs, I think these ones we have the what? We have some proper examples which are well known. Those cliff faces. You can also give the examples. But as far as this other question is concerned with the photograph, the example is the one you see there in the photograph. You locate its position. Say in the middle ground, or on the sketch you have drawn, you indicate it. That is the example of the slope. So someone is saying that even the ones of constant slope, that question there is not clear. It may not be clear. Unless he's saying that we go back to that, but I think we have taken long. We shall possibly come back to that after. But also, you rest assured that some of these things we shall be able to give them to you after, you know, some of them we keep on developing them. So when it is complete, we shall hand it over, and it will be uploaded on the what? On the Giantpedia platform. Or even in PDF form, we can also send it to you on your what? On your WhatsApp group. Click use there. Now, the other question was explain the formation of the drainage feature in the area shown on the photograph. What drainage feature was it? We had earlier on identified it as a lake. Okay. So from that photograph, when we look at the nature of the landscape isn't it a hilly or a mountainous area? Not necessarily mountainous, but at least a hilly area. So that's why I was saying here that the nature of the landscape suggests that the lake is most likely a lava dammed lake. Now, if we may talk of types of lakes, we have the volcanic lakes, of which lava dam lakes are one. Then we also have crater lakes, explosion crater lakes, highland crater lakes. Then we also have glacial lakes. We have lakes as a result of tectonism, which are downwarp lakes like Lake Victoria, Lake Kyoga, Wamala, Mburo. Those are downwarped lakes. We also have the glacial lakes, like the Thames or Sac lakes. The faulted lakes like Lake Albert, Lake George, Lake Tanganyika, Lake Latron, yes, and so on. Those lakes which are found within the Rift Valley. Those are the Rift Valley lakes resulting from secondary faulting. Now, with this other one, which is within the mountainous, which is within the hill area, would you say that is a faulted lake? If I go back to it, okay, this is what, because me had said that is a what? Now with this one here, it is hilly, there are hills here, there are hills here, there's a valley here, then there's a lake there. Do you think this lake could have been as a result of faulting? Do you think it could be a tilt block lake? Do you think it was a graben lake? Do you think this thing occupied a graben? When you judge from the nature of the relief, I don't think this one was what? Could have been a graben. Do you think it was a what, as a result of glacial action? A turn. You suggest this is a turn from the level, from the altitude where people have settled like this. Like, do you think this could have been a turn? I don't think. So the most probable type of lake this one is a lava down the lake. That's why I said, but it may not necessarily, but most likely it is a lava down lake. It it is not a crater lake. It will not be a crater lake from the nature of the what of the landscape. But there are times, purpose exams, you may not know, and I think can happen. They can consider, yeah, some types of lakes. But for our case here, let us note that it's like a ribbon lake. Ribbon lakes may be formed here in East Africa here. In East Africa, they are high altitude what? They are rather high altitude lakes. They are within the mountains. But in this case, this level may not have been greatly affected by what? By glaciation from the nature of the landscape, that's what we were saying. But in any case, yeah, there is no problem. So I'm saying that benefit of doubt, it can be a ribbon lake. So if it is a ribbon lake, you explain how the ribbon lake was formed. You explain how the ribbon lake was formed. But in this case, for today, which is the most likely one, like Lake Bunyonyi, like other Tanda, and so on and so forth, we would say that the lava flow resulting from a volcanic eruption spills across the river valley, and blocks the course of river flow. It blocks the course of river flow. So this results into the accumulation of water on the upstream side, forming a lake. Results into the accumulation on the upstream side. So now, okay, next one. And here is what? Some diagram to illustrate the formation of a lava dammed lake. We have a volcanic eruption here. The volcano, this could be basic magma. It flows and blocks the course of the river valley. So lava flow blocks the river valley. So the river is flowing, so it blocks it. Then now this is upstream. Now the water accumulates, the backbending. The water accumulates here, giving rise to what? A lake. Some of these lakes may include Lake Bunyonyi. Lake Bunyonyi. Upstream is the side from where the river is coming. So now in this case, the damming is here, blockage is here. The other side that way is downstream. This side where the water is coming from is upstream. This side is upstream. Water is flowing. The direction of flow of the river is that way. It is flowing that way. So this side is what? Upstream. This side is upstream, while the other side is what? Downstream. Downstream. The lower valley is what? Downstream. So this is taken as, or was drawn as seen from what? Above, though at an angle. So upstream, downstream. So it blocks here, the river is flowing, so now it cannot continue, so it occupies this valley here, and floods the surrounding low-lying areas, to give rise to a lava dammed lake. And in Uganda, I think the deepest lake we have in Uganda is a lava dammed lake, and that is Lake Bunyonyi. So the process of formation. We have said it is. We have said it is a lava dam lake. Process of formation, lava flowing resulting from volcanic eruption spills across the river valley and blocks the course of the river flow. This results into the accumulation of water on the upstream side, where the river is coming from, forming a lake. So this is a diagram to illustrate. Now, any question, or I could also ask now, like the other one, the ribbon lake. Anita, Anita, can you help us to also give an idea of how a ribbon lake is formed? We know a ribbon lake is a glacial lake formed as a result of glacial erosion. Places where abrasion could have eroded some sections of a glacial trough more than others, so creating deeper sections which are later on filled with what? With the glacial meltwaters to give rise to a ribbon lake. Possibly for exam purposes, yes, some people may. And the benefit of doubt, it is possible. Now, there's the other question now. Examine. So what was the question exactly? Is about relationship between physiography and land use types in the area. So relationship between physiography and the land use types in the area. So what is meant by physiography? So you are asked to describe the relationship between physiography and land use types in the area shown in the photograph. Physiography. What is physiography? Physiography, the time when we also identifying the physiographic features, is the relief of the area. So in other words, this question is requesting us to describe the relationship between the relief and the land use types in the area. So the relief features we had identified were the steep slopes, the gentle slopes, the lowlands, the basin, the hills, and so on and so forth. So now, these are just some of them. The gentle slopes. The gentle slopes have encouraged the construction of road transport routes as seen in the left middle ground. Gentle slopes have encouraged the construction of road transport in the left middle ground. I've also seen it. We wouldn't wish to just flash back to the photograph. There had been you also just see one other place is quite because of the hilly nature. Secondly, the gentle slopes have failed cultivation as seen in the foreground. You see there was a I hope you are seeing, otherwise today the network was really disturbed. Christine is saying that the upper area which the river forms from what does that mean? The upper area which the river, the catchment area. Upstream. Yeah. Okay, you're answering that question. Okay, so it's okay. Now, secondly, gentle slopes are favored. Crop cultivation as seen in the foreground. Then steep slopes have led to the practice of terrace cultivation. Steep slopes have led to the practice of terrace cultivation as seen in the left middle ground. So in the left middle ground, further into your photograph, there is what? There is terracing. There's terracing. And why the terrace cultivation is because of the steep nature of the slopes. Where it is gently sloping, we hardly see any terracing there. Then the lowlands and gentle slopes have encouraged settlement in the foreground. So where the lowlands are concentrated in, the settlements are concentrated in the lowlands. Settlements on the lowlands. Why are the settlements on the steep slopes? Because possibly it's very difficult to construct them. The lower gentle slopes for the foothills have the settlements. Now, what would one say about, I did not say anything about forestry because I was not so sure. What would one say about the trees of forestry and the relief? Anyone to tell us about the trees or forests? Anyone to tell us, because the photograph is not so clear, about the trees, about the relationship between the relief and the vegetation, especially the forests or the trees. Is there any relationship, or the trees are spread all over? If they are everywhere, that will then suggest that the relationship hardly exists. But if they're in a particular place or concentrated in a particular place, then definitely there is relationship. The question is there any relationship between relief and forestry? Or between physiography and forestry? No. Okay. So these are the clear ones that we can be able to see in the area shown on the photograph. The clear ones in the area we can be able to see on the photograph. So lowlands and gentle slopes have encouraged settlements in the foreground. Yes, yeah. Christine is saying that trees are scattered everywhere. So if trees are scattered everywhere, then there's hardly any relationship. Okay, so we now go to our next question. Saying that discuss the value of the drainage feature to the people living in the area shown in the photograph. So what is the value of the lake to the people living in the area? I think the photograph is still in your mind, and you could be having it somewhere. It is a source of water for domestic and agricultural use. the people around there, I think they may get water from there for use. Even their animals would get water from there. And also for the crops, to irrigate the crops. And that's what of domestic use and agricultural use, source of water. But I don't know whether the industry is there. I doubt the industrial use, unless it is cottage industry. But basically, I believe it is domestic water for domestic and agricultural use. Then secondly, encouragement of fishing for food and source of income. Yeah, there is there, though there's no clear evidence of fishing, but at least it would infer that a lake like that, which we have also suggested as a lava dam lake, is a what? Is a source of food through fishing. So fishing, the people can be engaged in fishing, which they may for their subsistence and also possibly sell some of the fish. Then thirdly, encouragement of water transport. Encouragement of water transport. So water transport has been encouraged. Water transport has been encouraged in the area. Just because of the lake. So where there's a lake, yeah, water transport. So that the value of that lake is for communication purposes. Then it's also may also be used for research and study purposes. People around the children for purposes of what? Study. Purposes of what? Study. Then it is also a lake, being a lava dammed lake or a lake within hills, is a tourist attraction. So the lake has promoted tourism in the area. And you know what tourists do? Tourists may bring in income. Tourists come, they buy products from there. At times there could be entrance fee, they may also pay. So tourism, promotion of tourism in the area. Then modification of climate, modification of the climate by acting as a source of atmospheric vapor. Modification of climate by acting as a source of atmospheric vapor. For saying that it rains, I mean the water body evaporates, providing vapor to the atmosphere, which vapor, as it rises, cools to form clouds, cools and condenses to form clouds, and which clouds eventually result into rain to favor crop cultivation in the area. So modification of climate by acting as a source of atmospheric water vapor. So there are those. I still don't know whether there could be more, could be other values, but these are the clear ones that we can be able to figure out. But there could also be what other values of the lake, water for agricultural and the domestic use, fishing, water transport, research and study, promotion of tourism, and modification of climate of the area. Those are some of the key values of the lake to the people living in the area. Now I to the question says here reads that X the question reads with the reason outline likely to be free in the areas with the reason outline the problems people in the area. Here saying that he faced by in the area. So those in fact the reason is asking for the reason. Do you some Yes. Okay. Suppose I go off again, you know that I'll be coming back until we do what? We'll finish, but we are about to end. Then we shall be handling some of your what? Your queries or your questions. Problems likely faced by people living in the area. Soil erosion due to the presence of steep slopes in the background and the left middle ground. So problems. So there is a problem of soil erosion. Soil erosion. Secondly, it's a problem of landslides. So suggests a problem of landslides due to the existence of the steep slopes. Landslides due to the existence of the steep slopes. Because where there are steep slopes, areas characterized by steep slopes are prone to landslides, being affected by landslides. Then there's also limited land for settlements due to steep slopes. Limited land for settlements due to the steep slopes. Limited land for settlements due to the steep slopes. You have seen at least there are some steep slopes which have been cultivated under terracing, while there are others you have seen in the background. There's nothing like what? Cultivation there because they are steep. Then also limited land for limited land for settlements due to steep slopes, then also limited land for crop cultivation due to the steep slopes. The same reason. There's limited land for settlements as one point, then also limited land for crop cultivation is also another point. Then also there's difficulty in the construction of roads. Difficulty in the construction of roads due to the steep slopes. So we said we only identify the one road. Otherwise, this place is quite wide. It ought to have had a network of roads. So this point could also be phrased like the same point as remoteness of the area due to the steep slopes. So the area is also quite remote. So one who gives the difficulty in construction of roads as one point and remoteness as also another, that is the same point, would end up getting 1 mark still for the same point, but phrased differently. So we've seen, because the emphasis was reasons with reasons. You may also locate the places like landslides due to steep slopes in the background or in the left middle ground. Leave the land for settlements due to steep slopes where you can identify them, you can locate, because you never know though the most important thing here was the reason, because they said giving reasons. Then also another thing is the threat from the wild animals due to the presence of forests or bushes. Threat from the wild animals. So there are those dangerous animals, there are bushes there, there are trees, so there are forests there, which may all scattered, but you may find wild animals may harbor themselves there. So that threat from the wild animals or danger from the wild animals is a problem to the people living in the area. Lastly, pests, problem of pests and diseases. Problem of pests and diseases in the area. Pests and diseases affecting the people, affecting the crops, affecting the animals due to the presence of the bushes, the forest, and the lake in the background. So the lake in the background may be a source of waterborne diseases, could be a source of waterborne diseases, which may affect human beings, also affect the animals. So it is mostly with human beings. Some of the animals in the forest or the bushes, there could be some ticks or some pests or some parasites which may come and affect the crops or the animals, which is also a problem. So those are clearly some of the problems likely to be faced by the people living in the area. Problems of the people living in the area. Okay, so now at least the other question was about the identify the weather condition being experienced in the middle ground of the photograph, then account for the weather condition you have identified. So that will require some information about what? About the climatology. I know many of you may not have, but at least there you have the background of that kind of weather condition in the what? In the background. Now, okay, what do you see? What weather condition is then the middle ground? Let's say up above the lake, above the lake. What weather condition do you identify there? Anyone to be able to tell us? Someone is saying fog. Shimira said it is fog. I can see it is quite misty, so we could say it is what? Fog. Now, what you have got to know is when it says that account for the weather condition you have identified, account for the formation of the fog. You know, there are very many ways in which fog is formed, but then in this particular area where there are hills and mountains, I mean, where there are hills and valleys, what is the main cause, the primary cause of fog in the area? That is what you should be able to explain, not other what causes of fog. The occurrence of fog in highlands like the Chigezi Highlands, that causes the fog there, which appears in the valleys at dawn or very early in the morning. So occurrence of fog, then explaining factors which could have influenced the formation of fog in the area. Okay, we may stop there, then be able to hear from you people in case of anything to do with the questions. To do with some questions or some issues as far as what we have been discussing is concerned. You may feel free to ask either in the chat, or you can unmute yourself and you ask. You ask, yeah, we shall be ready to do what? To explain. Teacher, what type of fog is there in the photograph? Who can tell us the type of fog found in the area shown in the photograph? What type of fog is that? Or who could be knowing the different types of what fog? Can we name the different types of fog? Not like the one who asked about the type of fog. That is who? Shamira. Have you heard of any? That means you have an idea of the different types of fog. Okay, the fog we have there is the valley fog. That is the valley fog. Fog which occurs in the valley at dawn. So what could have been the cause? So the existence of what? Of the valleys. Let's say this one is the what? So there is this is a hill. This is a hill. This is also what? A hill. A hill. So during the day, these ones are heated very fast. Yeah, the upper slopes are heated. Upper slopes are heated. But then at night, these upper slopes cool very fast. They cool very fast. The upper slopes cool very fast. Now, what happens when these upper slopes cool very fast? The air next to them, the air resting on them also cools. Now, this cool air, cold air is dense. So cold air is dense. Now, this air here will now be what? It will now be cold. It will be cold. So also here it will be what? It will be cold because of radiation. These upper slopes radiate their heat and they cool, and the air also becomes cold. So this cold air is dense. But in the valley, this is sheltered. This is sheltered environment. So when it is a shelter, it is quite warm. It is quite warm here because it is sheltered. So here there is general what? Warm air, general warm air. Now what happens? This cold, dense air comes down under the influence of what? Gravity. The valley. So it drains. And the process is called air drainage. Air drainage. Air drifts down to the what? Valley. Air drifts down to the valley. So cold air drifts to the valley. Cold air drifts to the valley. So when this cold air drifts to the valley, this warm air which was here is displaced what? Upwards. I can say warm air from the valley, warm air from valley, from valley, warm air displaced upwards. So the warm air is displaced upwards. So when this warm air is displaced upwards, now this higher altitude area, this higher area now has warm air, But then we said that this cold air, which was originally from here, has drifted what? Down. Because it is dense and heavy, so it subsides. It subsides or it sinks into the valley. It sinks to the valley, displacing the warm air upwards. So now in the end, you'll find this valley area. Valley area will be what? Cold. Valley area will be cold. So this cold, it will be cold here in the valley, while higher above it is what? Warm. It is warm. So what kind of phenomenon is this? The higher you go, the warmer it becomes. So this is a temperature inversion. This is now temperature inversion. The higher you go, the warmer it becomes. These places will be, this is now temperature inversion. At higher altitude, it is warm. At low altitude, it is what? Cold. Now, this cold air which comes here, it could have met a part of the warm air, which was moist. So the moisture in the warm air, which was got here, which cooled, the moisture now does what? This is cold air. Now condenses the moisture in the warm air, which was here. So when that moisture condenses, it forms what? It forms mist. It forms a surface cloud. And that surface cloud is what we call fog. That surface cloud in the valley is what we call fog. What happens, as we have said, is the cold air from the hills or from the upper slopes sinks to the valley, displaces the warm air in the valley what? Upwards. There was warm air in the valley because the valley is sheltered. Then this cold air of the which comes to the valley cools and condenses the vapor which was in the water valley to form fog. So that's how valley fog is formed. So that's how valley fog is formed. So it is valley fog. We have accounted for the formation of fog. Yeah. Okay. So I think this was the only question which was asked. So I think it is already for some of you are supposed to go for mathematics, or there are some who have been already left because it is 4. So I wish to now stop here because I think we ask in case of anything, one can be able to do what? To ask. Otherwise, wish you the best and have a great evening. For those who are going for mathematics, wish you the best too. So I think we can, if there's everything, if there's anything, yeah, at least we have exhausted, we have almost exhausted the thing. So about the fog issue, that was the last bit. Then the other last question was an area where the photograph could have been taken, and that area is, you can as well suggest also, it must be a hilly area, which has some, could be with some water bodies or something like that, generally hilly area like Kabale, Chibezi, Kisoro, Bundibugyo, such places. Okay. So Christine, Michelle, and all the others. Wish you a nice weekend. Hope we have learned something. And next time, I think we shall now start with another topic here. Another topic which could be mass wasting. All right, wish you the best and have a nice weekend.